Okay, we're to find the equation of the hyperbola that has vertices 0, 4, and 0, 0, and passes through root 5, negative 1. I would find a graph to be really helpful for this, so we're going to go ahead and sketch this. It's really surprising how many times really strong math students, I think we get so involved with the hyperbola stuff, that we don't take care of the basic and things that we should be very, very good at this time, such as plotting those 0.0400. Take your time. Let's get those right. Too many times I see a 0, 4 plotted as a 4, 0. So we're going to plot 0, 0 and 0, 4. And those are the vertices of the hyperbola. And for the equation of a hyperbola, we have perhaps x minus h squared on a squared minus y minus k squared on b squared equals 1. Or maybe we have y minus k squared on a squared minus x minus h squared on b squared equals 1. So there are 5 things we need to know to come up with the equation of the hyperbola. We need to know h, we need to know k, we need to know a, we need to know b, and we need to know what direction the hyperbola is opening in. In this case, given the vertices, what all have we learned here? Well, if these are the vertices, I know this hyperbola is opening up and down in a y direction, so we are talking about this equation we're going to put this into. So I've got direction. I also know the midpoint is our center. I've got the center at 0, 2. And one more piece of information we know. This distance 2 is A. A is 2. That's an awful lot of information for us to be given from just having the vertices. We have everything except for B. So I'm going to go ahead and set this guy up at this point. We have y minus the y coordinate of the center, 2 squared on A, but A is 2 squared, minus x minus 0 squared equals 1. We're just missing B. If we just knew what B squared was, we'd have it made. And I haven't even looked at this piece of information yet. So this tells us that we have a point at root 5. So let's go root 5, a little bit more than 2, and negative 1. We have a point somewhere over in here. Well, that would give me a value that I could put in for y and for x and allow me to solve for b. So let's go ahead and do that. In for y, I'm going to put negative 1. So I get negative 1 minus 2 squared on 4 minus in for x root 5. So root 5 squared, 5 on b squared equals 1. And I ought to be able to solve for b squared. So at that point, I think I'm going to go ahead and multiply both sides by 4b squared here. So I'm not working with fractions anymore. Okay, so excuse me. As my first term distributes, I get negative 3 squared. I get 9b squared. The 4's cancel as I distribute. Minus, as I distribute to my next term, the b squares cancel. I get 20. And then distribute 4b squared to the other side equals 4b squared. And now I just solve for b squared. So I come up with, subtract 4b squareds, I get 5b squareds equals, add 20 to the other side, 20, and b squared equals 4. And at this point, we'd probably want to rush to say what b is, but to be honest, we don't really care what b is. At this point, we just care what b squared is. So my final equation ends up being this. like a graph is very, very helpful on those. But when they give us vertices, they've given us an awful lot of information. When they give us a solution point, this guy, you can bank on substituting those values in down the road to find a missing value.